We are going to write some tests. One of the problems of writing your tests first is in my experience, the test code, a lot of the test code will end up being wrong. And you might say, well, that doesn't make sense because the tests are supposed to confirm the accuracy of the code, blah, blah, blah. Well, yeah, they are, but the tests really serve as, when you're trying to get code correctness, they serve as a redundancy, right? The correctness of the code comes from the fact that the tests and the code both agree with each other. But to find that agreement point between the test and the code, you're likely going to find both bugs in your tests and bugs in your code. And you might say, well, if there's bugs in your test and bugs in your code, what's the advantage of writing a test in the first place? Well, the advantage of writing a test in the first place is because both the tests and the code have to agree, it means that you're going to get a lot of errors until both the tests and the code agree. And you're going to have to keep on bouncing back and forth between the tests and the code until they both agree. So in practice, that's how it is. Now, people will say that, oh, that's not how it works, but that's how it works. Unless you're doing something dead simple like setting a getter or putter, but we're not doing dead simple things. We're doing pretty difficult things here. I mean, not super difficult things, but pretty complicated things. With that, writing the tests first, I think, is a bad idea. Because you're just gonna have to come back to them. You're gonna have to come back to both the test code, which probably has bugs in it, later, and then you have to come back to the actual code you were writing as well. You're gonna have to go revisit both of them. And we really want to focus on one thing first, right? We want to focus on writing the algorithm. Then we want to focus on writing the tests, and then we want to focus on finding out where the bugs are, right? Are the bugs in the algorithm or are they in the test code, and then fixing that up, right? So we want these three phases of write the algorithm, write the tests, and then focus on getting them to agree with each other. And if you try to do both of those at the same time, I personally find that it leads to a lot of context switching, right? When you talk about Scrum talks about, the lack of efficiency when you start to do a whole bunch of context switching. Like if you have projects A and B, it's better to finish project A and then finish project B. That's going to be faster than working on project A and B simultaneously, because you have to switch between one and the other, and every time you switch, there's a context switch penalty. So I think the test code also has a context switch penalty. So what we're about to do, write these tests, is a bad idea. Because we haven't even finished all of the algorithm stuff, and now here we are writing tests. But we've kind of put ourselves into a bad position where we have all these loose ends all over the place, and we need to start damage controlling. And one way to start damage controlling is to actually put in tests for everything we've written so far. Because what we don't want to have written this massive amount of code and not have any tests. So in this case, doing something in a more, not quite a test-driven development way, but in a tests-first kind of a way, might actually be the best way to go for these circumstances that we're under. There's no silver bullet for everything. Sometimes the test-driven development methodology is going to work. Sometimes doing tests last will work, and sometimes it's a mix of both. So anytime you try to impose some type of rigid structure, then you have a non-optimal solution. What do I mean by that? Well, think about it. In game theory, there's something called a dominant strategy. A dominant strategy is the strategy that usually works most of the time. And if you think of test-driven development or any type of dogma, what those are they are just dominant strategies. They're dominant strategies. Like, if you do this most of the time, you're probably going to end up all right. And that's good. I think, if you don't have any other guiding principle, like, I don't know, using your brain, then yeah, use some type of dominant strategy. But if you are going to use your brain, then question if that dominant strategy is the correct approach at this time, you know? So what else? We need to figure out how we're going to mitigate this, though. We need to mitigate the damage that we're about to do. I mean, there's no way we can't do damage right now, because we have all these loose ends, and we need to kind of like cauterize the wounds, right? And when you take like a branding iron to someone's skin and they're bleeding out, right, you're going to stop the bleeding, but you're also going to give them another wound, right? You're going to give them this huge seared burn mark thing that's cauterizing the wound, right? So as we kind of stub in these tests, we're kind of like cauterizing the wound. We're trying to solve one problem, but we're giving ourselves another problem of having written a whole bunch of test code before we're ready. Because the chances that we write our test code perfectly the first time without any bugs, that chance is about 0 from my experience. 0. So in order to mitigate that, what we're going to do is we're going to write the test code, but we're going to only write like a few test cases, but we're going to flesh everything out so it's ready to add more tests later. But we're going to put the bare basic tests, like simple smoke tests, in first, and then we're also going to do like a vital to-do in here to make sure that if we ever forget about this, we have a way to crash the system and see a point that needs our attention. So right here we can do like AAC in 2020. Actually, you can't see this yet, so let's go to the code now. So in this test code, what we're going to do is we're going to do AAC vital to do, and actually we have a manager for that now. So AAC 2020 to do man vital. So that's a vital to do. Finish tests and 2020 1231. Let's just say 3:16 p.m. So I really don't have much. I just want to make sure this is unique. I don't really care what the message is. I could say, you know, add more test cases to this function. To make a little note that we want to just add more test cases to this function. And I see I have an error finish test code test table. So yeah, last night I was thinking about it. I didn't really want to write this code. And now that I've thought about it, it's like not only do I not want to write this code, right, but I just wanted to like get it done quickly. But now that I think about it, we really should do it in the most robust way. It's going to save us. It's going to save us time in the long run. So we need to create a test table. And it looks like we have, in some cases, we have uint16 values for like these global values. So we're going to need to use at least uint16s for this table. And we can call it, table UTC for unit test, table unit test code, right? General to specific, table, and then unit test code. And we need the number of tests, and I don't feel like putting all these macros here. I feel like they kind of belong glued into this test. And I see paired unit tests. Yeah, so since this is already kind of indented, right, we could do define num tests test cases 001. It will make that. I don't know what that'll be. I guess right now we'll do 4 because there's 4 quadrants, so that'll be the minimum number of test cases for what we're doing. And define num test elements. Well, let's just do datum, just because then I can keep this shorter. So 1, 2, 3, 4, 5, 6, 7. So it should be 7. then we can take these defines here and put them down here at the end of this paired unit test thing. Get rid of those. As far as the number of test cases for over here, I don't know what that number is going to be yet. We should probably keep it at the same thing. All right, we should probably do 4 and 7 for both of these. Right, and now numbering it like this is obviously kind of vague because you're like, well, what do these numbers mean? Well, this number is going to be the Glock picks to pain picks. And then 2 is going to be pain picks to Glock picks. But we don't really have much room to write that. Like, we could kind of write it there, but then we run out of room for putting our little checksums. We could say, we could, if we want, we might be able to say something like this. Like, if we wanted to, right? Glock picks to pain picks cases, datum, cases, datum. Like, we could probably do that. Why not? Why not? Why not do that, since it's a little bit less obtuse than just having, you know, the numbers there. So let's just do pain picks C2 Glock picks. It's also going to make it a little bit more obvious if we're using these in the wrong place, right? Because this is Glock picks to pain picks, therefore we're going to use one that says Glock picks to pain picks, right? Okay, that's fine. I think we'll go with that. It's a different way than we've done it before, but I'm all for experimenting and trying to find the most optimal way to do things. So let's try this and see how we like it. Or if we think this is just too verbose and ugly, we'll decide on that later, right? So we have 4 defines at this point. So let's make a little checksum to tell us that, hey, we got 4 defines. Okay. All right. Now, let's continue this table, and also let's make a little note here. You know, tab UTC table unit test code. Right? It's a table of unit test code. That's what that means. And we can take both of these things here, these macros, and we can say, take that, and multiply them together. And that's how we're going to know how many elements need to be in this test, or in this table, right? Now I don't know exactly where I want to put this pointer, or not this pointer. Well, that's the problem, is that I see it over here, and I think it looks like a pointer, and I even set it that way. I don't know where we want to put this multiplier. I kind of like it right there, but then it's like, maybe it makes sense here, but then we have this gap between our alignment, which makes things a little bit confusing, but at least we can be like, oh, this is probably a multiplier. So I don't know how I want to do this, but let's just kind of break it apart like this, I guess, for now, and start adding some test case code. And our numbers are going to be no more than 3 digits. So we could start with some hex values of just 0. So if this is just to get something that has the correct spacing. So tile quad, tile exponent, and tile layer, all 0. Then the local tx, also 0. And the local ty, also 0. And then the global is also going to be 0 on both the x and y. Okay, so there, we have like just enough room, it looks like. 1, 2, 3, 4, 5, 6, 7 for everything that we need to express in this test table. So the next thing we could do is, well, can we get doesn't look like we can really get a explanation of everything in here, so what we could do is kind of shorten it. So quad exponent layer, and this is like LTX, LTY. Yeah, that's kind of confusing. Let's call it local. Local and local, and you're just gonna have to know that one's the local x, one's the local y, and we keep to a pretty good ordering, right? X is before y, so this is global and global, right? For the global tx, global ty. We just want some nice little labels here. When we're looking at these test cases, well, we know what's going on, right? Okay. Let's look at the diagram and think about what things should be when we input different values. This says Glock picks to pain picks, and when I think of that, oh, this is actually our input for this is actually these guys here. Our inputs are these last things because it's Glock picks to pain picks, but we kept the signature where everything's in the same order. And when we call this, this should actually be, we should actually be making pointers of certain things. Yeah, so we see Glock picks to pain picks, we see all the first things are kind of addresses. And we need to take these and just kind of wrap them with addresses, because these are what's actually going to be returned. And you can make a note that these are inputs, and these are outputs. And I just want to change the alignment like that, just so that when we're looking at it, we can kind of easily see the difference between the sections, right? Because we have the spaces here. If we align them next to each other like this, it could be a little bit harder to see which sections belong where. We'll just call it inputs, outputs like that. Now, obviously, a very bulky way to call a function, and that's why we're going to do it in a nice little loop. What are the next? We're going to try to do 4 basic tests. And for those 4 basic tests, we might as well start off with the quadrant. So 0, 1, and 2. And, oh, I guess for... Oh, no. These quadrants, we want to start... There's only 3 quadrants in terms of the tile exponent size. But for the main outer quadrants, we actually do have 4. Like these quadrants here, we have 4 of them, right? 1, 2, 3, and 4. So let's just do tests where all the values are the same except for the quadrant. So we'll take this and we'll just kind of paste it a few times and then change what we expect. We're just using hex values right now to align things, but as we change things around and certain things become non-zero, then we'll alter that. So, for example, this could be, I'm going to make this a 1. Now, we could still use hex values, right, because we're not overflowing yet, where the hex version of these would be the same, but we don't want to confuse ourselves. We're only going to look at hex 0, hexadecimal 0. Anything else is going to be in decimal, because I think all of us should be... All of us, no matter how acquainted with hexadecimal we are, should at least know that, you know, the thing with all zeros is equivalent to decimal 0. But if we ask anything else, anything more, I think that's asking a little bit too much. Even if it's just, you know, 0x01, 0x02, which are still equivalent to their decimal counterparts, but I think that just makes the code confusing to read. So we're going to just do everything with quadrants 1, 2, and 3, and be like, okay, well, how does that change what our values should be? Well, this quadrant over here should now be 256, 0 in the output. So over here, we're going to expect 256 and 0. And we're actually going to make this 0 as well, like this, just because these are the values we kind of touched and considered. Now when we go over to, so this is quadrant, this first quadrant, everything's 0. This quadrant, 256, 0. Down here, it's inverted, so the y is the 256. Okay. And then the last one over at this quadrant, it's going to be 256 for both of them. And that's all we're going to do for these tests so far. The reason is, like I said, there's a high statistical likelihood, from my experience, to actually get these tests wrong. And so we don't want to write too many tests right now, because there's just the potential that we're going to write them wrong, and then we're going to have to get back in that headspace and figure out what we were thinking when we wrote those tests. So we want to just start off with a few tests that are just simple, and then later we'll come back to these tests and write some more, you know? Okay, so now that we've done that, we can see that we have 4 test cases, and for each test case there are 7 pieces of data, or 7 data points, or 7 datum. And we can also make a little checksum here, right? We can go we could go 1, 2, 3, 4, 5, 6, and 7, right? So we can see the 7 datum, or the 7 data points. I'm not sure about the exact verbiage for that. Datum is supposed to be singular, and data is supposed to be plural. So data points, I don't know. I think the verbiage around that is, the English around that is probably just a little bit weird. Okay, so we have 4 and 7, and we have 4 and 7 here. So that's what we did. So that's fine. Now for this test here, one thing we want to make sure is that we don't accidentally use values that were just never initialized. So at the beginning of each test, we should set some type of trap value. So let's take 2 to the power of 16 and see what that is. See what our maximum value for integer is. So yeah, about 65,000. And since it's about 65,000, we could say 60,000. Okay, we'll do, our trap value is going to be 60,666, right? So something where we can fit it. So for everything in here, we're going to take tile claw, everything, every single thing, 60,000. Right. And we could also do, we have 7 things, right? So we could do all from 0 to 6 if we wanted to. We could do 1, 2, 3, 4, 5, 6, 7. We could do this, and then we could do 5, 5, 5, 4, 4, 4, 3, 3, 3, oh god, 3, 3, 3, oh god, that's not 3, 3, 3, 3, 2, 2, 2, 1, 1, 1, and then, you know, just zeros. So let's just do the, I changed my mind, let's go up here and make this 7, because the zeros don't really look like anything. So this is still in range. Now if we do anything else, right, we can't make this accidentally 7 because that would be out of range. So why not, instead of a 6 here, just make that like 1,000, just so that we don't accidentally go out of range. Alright, so 10,777, 10,666, 10,555, 10,444, 10,333, etc. And these are all going to be trap values at trap value. And I don't think we've used a plural trap values in our notes before. So let's just make sure that we have that, and if we don't, okay, we don't have that, but I'm sure we have trap value somewhere, yeah. So we have trap value, but we don't have trap values. So you know what, we'll just make a new section up here, and just say at trap values, and we'll just denote that, that when you see this, it just means, you know, see the plural form of at trap value. Right. That's all we mean when we have a section like this. And we can take these over here. We're going to paste them down here now. And then we're going to realign. So what is a trap value? Since we're already here. So the time of this video is 0 hours, 25 minutes, and 35 seconds. A trap value is an intentionally bogus value that we hope to notice when debugging our code. Usually I use it to catch when I act. Okay, so that's what a trap value is. Okay, so we're just kind of re-describing what a trap value is. A trap value is an intentionally bogus value that we hope to notice when debugging our code. Usually I use it to catch when I accidentally forget to initialize a variable. It is called a trap value because we are setting traps for ourselves. But if things go wrong because we get in our own trap, it is easier to fix than if we just get wrong results in our code with no clues left for us as to what we did wrong. So yeah, we have these trap values. Now obviously we have to change all of these here, right? We gotta column select, change all those. And now we need to actually load all of these test cases. So to load these, let's load the first one. Tile quad equals the test index times test stride, I guess. Test index test times test stride, sure. And actually no, let's do base equals test index times, instead of calling it text stride, let's just take the actual thing, right? So this thing, datum, so the number of datum in a row, base is test index times stride. Okay, so the base is the text index times the stride. We're also going to need a value for that. So let's just use a int32. No need to get, oh, that's bad. Might be out of room on my external drive. Hold on. Let's make sure we're not like out of room here. R drive. Are we out of room now? Well, yeah, that's a problem. Okay, so hold on. We got a problem. Because this code base itself is kind of like in on that drive, so we have to do some emergency cleanup here. So let's see, third-party stuff, Doom codebase, that's cool and all, but it's only 29 megabytes, it's not a big deal. But right now we have emergency cleanup, we absolutely have to get rid of some space right now, so let's delete this. Yes, Doom, third-party, yeah, we can always find it again on GitHub. Tree repos, etc. Now the backups here were like, yeah, so we got plenty of gigs here. For Git, right, so this is where we have like AAC 2020. So we have tree repos, and then we have like bear repos, I believe, or tree repos might just be a place where you give things to like backup, I believe. Okay, here's what we're gonna do. We're gonna do a git bash here. Anything that has a remote branch. We're gonna. So I see that this has kind of like, it has no remote branch, right? So what we're gonna have to do is we're gonna have to take some time to back some stuff up here. We need our repo drive. We're gonna back stuff up on GitHub. And then, yeah, so www.github, because I don't know what is, because I might have some repos that don't actually correspond to, yeah, hold on. Okay, so now that we're signed in, we're gonna look for JM Vulkan C++, which is something I really don't care about, but if we're gonna back it up, let's kind of look at it. So it's like 55 megabytes. So let's just throw that into a new repo. So JM Vulkan CPP, just gonna say new, and it's just going to be called JM Vulkan CPP. Description. Trash. Trash. Removing. Really, it's just trash. I'm just freeing up space in my thumb drive, but I'm hoarding. So, let's keep it private, because we don't know what's in it. You know, let's not kind of like push up anything. We have no clue what we put in there. So we'll keep it private, and yeah. So we'll create this repo. And then we will take this thing here. Just going to copy and go into the JM Vulkan thing here. And go git bash here. You can see this is really old code because I'm still using kanji and things. And git status. Okay. Git remote -v, and we're gonna do a git remote add, and we're gonna do git hub, then we're gonna right click to paste. Okay, git remote -v, git push github master. Then once you've pushed to GitHub, we're just going to nuke this. We're going to nuke this whole thing and free up 50 megabytes. Yeah, we just need to do some housekeeping. I'm going to guess that's our master shortcut repo probably has slowly taken up more and more space, and now we finally kind of ran out of space with that. And eventually, if our master shortcut repo starts taking up too much space, we might want to actually nuke the repo and make a new one and just call it like AutoHotkey 4, and it's just going to be all the same stuff, but we're going to remove all of the versioning and just be like, oh, we forgot how we got here, which is kind of scary. So git status, but a lot of the versioning control stuff is taking up a lot of room. Sometimes we accidentally commit large files and they're in there. It has a lot. It definitely probably has a lot of cruft. So git status, yeah, okay. Okay, cool. So let's actually check on GitHub and make sure that, you know, we have something here. We're pretty much just gonna forget about this. Forget about all this code. Alright, we have like, yeah, we were just doing some crazy C++ stuff, trying to like, because we were like, oh look, C++ will let us use Unicode variable names. Ooh, this is fun. Let's have some fun with this and do some crazy stuff. And we're just trying to get Vulkan to work, and I'm like, you know what, we're getting way too complicated here. We don't know enough to really use Vulkan, and so we're gonna just do OpenGL, and then eventually, if our needs are like, you know, if we become such good graphics programmers that we're just doing such wild and crazy things that we absolutely need Vulkan, then we'll kind of like turn to Vulkan. But for now, we're just gonna stick to OpenGL because some of this is just kind of crazy. Okay, so now that we have that and we've kind of exported that, let's just go take this. We're just going to delete it. Yep, because we're never going to touch it anymore. We're never going to touch C++ again. And we're probably not going to touch Vulkan for a very long time. So we have JM OpenCL. Let's look at that. So properties. Okay, so we got 75 megabytes. And if we look at this, we see some kind of crazy kanji stuff. So I'm going to guess we're doing C++ again. Yeah, so C++. And if we look at, yeah, just some crazy code. So language. Let me just gonna, yeah. So yeah, and the problem with Unicode is, depending on your font, sometimes it will align and sometimes it won't, because some fonts will treat kanji as exactly 2 Roman characters, which is nice, because I think that helps you align everything. And then others will use like weird fractional amounts for a kanji, and then things don't align with the monospaced font. So finding a monospaced font that supports kanji in a way that I would deem correct is very difficult. And then if you start using these wide characters for Roman, this is like a Roman wide D, so it's not just your normal ASCII D, it's like a Unicode D, and so it's specifically fixed width wide, and so this character, this D, should also be the width of 2 normal Roman characters, and depending on the font set you use, that may or may not be true. And so to get a font set where this D is double wide and this kanji is double wide, and then all your Roman characters are single wide, and then everything's monospaced, to get that to happen is really difficult. And then to get that to happen and to have /0s and I's and L's that look sufficiently different and have it be a friendly programmer font, to get all that stuff to work together, almost impossible. Osaka monospaced almost does it. Osaka monospaced, and then there's another font called like Nimsum. Very close, but you just end up battling the font, right? It's already hard enough to get a good programming font, and you start trying to do things in Japanese, you just made your problem a whole lot harder. So So that's kind of that's one of the reasons we ditched that. Also, just the thought that other people who are going to use our code base aren't going to be able to use our code base if we're typing in Japanese characters and using special scripts to type those characters. That's why we are that, that's, if you want to know why the name is Kanji Coder, this is kind of the legacy of, why that is why that is. So let's go back to Heavy Metal Cookies and see, do we have a JM OpenCL in here? So let's search repositories. Where is our little search button? We had a search button, did we not? Where'd it go? Am I just not seeing it? Let's just go back and see how do we search for the original one? Did we not kind of... Maybe we didn't search for it, maybe we just tried to create it and it allowed us to create it, so we're like, okay, that's good enough. Is that what we did? No, here's the repositories, so, oh, no, this is new, though. Okay, whatever. Let's just call it... Here's what we're going to do. We're not going to worry about that. We're just going to be like, JM OpenCL. It's going to correct us if it already exists. So we're going to call it JM OpenCL. And say new. And JM OpenCL. Trash. Freeing up space on thumb drive. Alright, so I'm just going to make a note that I really don't care about this thing, but I care enough about it not to nuke it into oblivion, right? Like, it's stuff I wrote. I may want to reference it in the future, even as an example of just how batshit crazy things can get, and examples of why I don't do things like that anymore. Public. Yeah, so let's create this repo. And now let's take the git URL. I don't know what they're talking about. Take this git URL, copy, go over to here and do git bash here. And just do git status. Okay, git status. Just remote. Okay, git add remote GitHub, and then paste what we had from that GitHub page. Oh, sorry, git remote add. We did that in the wrong order. Okay, now we're gonna paste that. Now, if we do a git status, and git remote dash v. Let's see what our remotes are. Okay, we have a GitHub now. We're going to do a git push to GitHub master. And if that works, we're going to delete this from our thumb drive and just kind of keep on doing housekeeping. And I'm guessing the big offender on this thumb drive, besides kind of nickeling and diming myself with like 50 megabytes here, 50 megabytes there, is probably the shortcut repo. I think the shortcut repo might be on here, and the shortcut repo is like gigs. So it's like all of the knowledge I have touched in the last 3 years is in my shortcut script. But yeah, we need to take time to clean this up, because if we don't have any memory on our thumb drive to work on this repo, then we're going to have some trouble. You're going to be like, well, why are you doing everything on a thumb drive? And the reason I'm doing things on a thumb drive is because in the advent of a catastrophic failure of my computer, I do not want to have to salvage hard drives. I mean, yeah, okay, you could take it someplace, or you could have the equipment on hand, but in my experience, that is a pain in the ass, and sometimes I never actually get around to it. I'm just like, you just leave that hard drive laying around for a few years, and you're like, yeah, eventually I'll get to it, and then eventually you just have moved on. It's been so long that you're like, you know what, everything on there is so old that it doesn't matter anymore. And then you just throw it away, and that's how a piece of you dies. So, let's not do that. Okay. So now that we've loaded that up there, we should see like the little index, right? So we have this, right? So everything is, right, this is 3 years old, right? It was 3 years old and never on GitHub. So 3 years ago, we started messing around with C++ and OpenCL and Vulkan. And now we're going to be like no Vulkan and no C++ just because it's too difficult. Well, C++ is because it's too convoluted. Vulkan because it's too difficult. OpenCL, actually, I do like OpenCL, but we don't have a guarantee that it's going to be efficient from my experience. Maybe I just got the wrong graphics card and it works on everybody else's graphics card, but it does not bode well that my graphics card, which is, it's a GTX 960, it's an NVIDIA graphics card. If it's a major graphics card vendor and there's a major problem for this library, that scares me away from it. And maybe that wasn't intentional. Maybe NVIDIA was doing one of those stupid Microsoft things where they're like, hey, let's make sure everybody uses CUDA by like putting in this huge problem into our driver, right? Like that, I wouldn't be surprised if that was a thing, right? But the thing is it's created problems for me. If it creates problems for me, it gots to go. I don't want to deal with problems like that. And there's a thing where like Microsoft did something similar with like there was a thing called Research DOS, and Microsoft intentionally put a bug in their operating system to make people wary of installing Research DOS. There's a whole like little mini documentary on it. So yeah, I wouldn't be surprised that don't think that we're beyond, that we've moved past some type of era of being horrible humans. We're still just as horrible human beings as we ever have been. We just have like a veil of civility over everything. So, we still have landlords, we still live in a feudal society. Might is still right. It's just that instead of just being strong, might is also manifested in just being really smart. So the might is right still applies. It's just that what is might has changed. So as we code things and we make money on them, we're still, that's still might is right, right? Because we're just using the might of our brain to gain power, right? And so the reality of the world is kind of it's not all rainbows and sunshine, So now that we have that, let's kind of look at, I kind of ranted. I don't know if that's a little bit too political. It's obviously kind of nihilistic, at least. So JM OpenCL, we're going to delete this. And yes, I want to delete this. Okay, so then we have like a John Mark JavaScript thing. And we were doing like a lot of interesting JavaScript stuff, but I don't feel like doing any JavaScript stuff lately. I'm kind of focusing on C now. It's only 4.09 megabytes, so that's not bad. The Memory Palace thing, that was a little demo thing. That's more, probably because it's using some like Node.js kind of stuff. Fake binary tree sort. I mean, there's some interesting things in here, for sure. But we gotta we're kind of like in a, we gotta be decisive and kind of figure out like where do we want to focus all of our effort right now. If we try to scatter ourselves in all these different languages and all these little projects, we're never gonna get anything substantial done. We need a concentrated effort. So even though I think some of this stuff is cool, we should kind of like tuck it away and kind of forget about it forever. So let's do a git bash here and see if we can kind of tuck this away as well. So git status. And we can always pull it back down from GitHub if we like really were like, hey, where was that thing that we had? Okay, git remote -v, and this might already be, nope, so what we're going to do is, it's called mempalace, so let's take this and go create another repo. And also, this might, our contribution graph from 2017 might, and 2018, we might actually start to see these contribution graphs all of a sudden like get larger, because it looks like we have a lot of old code from 3 years ago, 2020, 1 year, 2 year, 3 year, from 3 years ago that was never put up here, and so we're kind of like archiving very old code, so we might actually see that contribution graph change. Because I was wondering why I didn't see any contributions, and it looks like it's probably because I wrote a lot of code, put it in version control, but I never put it up on GitHub because I'm like, whatever, these are just like little things, I don't care. So in my repositories, let's create the mempalace thing. So new, and that was mempalace lowercase, so let's just keep the case of whatever the folder names were. So mempalace as in a memory palace, and we're trying to do like some 3D memory palace kind of application. Trash 3D memory palace JavaScript stuff, and who knows what else. Screenshot in JMIM. Right, so we have a screenshot of this and working in our tech demo gallery, so we can make a note of that. Yeah. Public. Oh no, we want to make that private. Oh god, did I accidentally make the other thing public? I don't really care too much, but we're going to create the repo called mempalace. And then we're going to take this, and we're also going to do a little git bash here. Git status. Git remote. Well, actually, git remote add GitHub. Paste that. Git remote -v. Git, this is just to check what my remotes are. Git push. And then GitHub master. And then once that's pushed up, we're going to nuke this as well, right? So we're just going to kind of look at all the code that we've written and be like, nuke it, push it up, nuke it, push it up, nuke it, right? And that is kind of scary, because that means that everything is going to be centralized on GitHub, and if anything goes wrong with GitHub, then we're in trouble. But I'm not too worried about that. You know, if it's something more important, like if it's my personal code base, yeah, we're not gonna do that to like the main code base I'm working on, where I'm investing a lot of time and energy. We're gonna make sure we have other copies besides just something on GitHub, because we don't want that one point of failure. Even though I know GitHub probably distributes their things on multiple servers and whatnot. Okay, now we want to just check, verify that the stuff is up there. So let's kind of refresh. And yep, so that's there. Very cool. Okay, so the memory palace, we can kind of delete that as well. Cancel. We gotta close this terminal. So exit the terminal, and now we can probably delete this. Okay. My go path, I don't know why it's like that. Oh, this is probably setting up stuff to get Go to work. 131 megabytes. That is something I might want to take a look at. We got Heroku Chrono by date. So this is like chronological things. This is like a kind of a chronological diary thing. And we kind of decided that we're going to put all of our chronological stuff literally in just one master linear text file. Is kind of how we decided to do that. But before, when we're trying to linearize information, and we thought that this was like a good way to do it back in 2016, 2017, it seems. And it was an alright way to do things, I think, but there's a lot of administrative effort to do things like that, and then you get these like miscellaneous files. We get miscellaneous files in things, and like really old patent stuff is in here as well. So let's look at Chrono by date. It actually looks like it has a Git thing. 296 megabytes. Yeah, so let's take a look at this, see if we can push this up to GitHub and forget about it. And also, let's make sure that chrono... I'm going to make sure that chrono by date is not, like, already referenced on my thumb drive, because it might be. Oh, it looks like it's on some other things. Looks like it's in some other places, and that's fine. So, I'm gonna make a note that, so is there Trija in here? Hold on. H. I think if we... Yeah, so, yeah, I'm just making a note. Okay. So I was just making some notes as I'm kind of removing things. So chrono by date. Git bash here. I kind of lost track if I had made a thing for this yet. So let's do a git status. Git remote -v. Let's see, do we have a remote for that? No, so we don't have a remote. Oh, we did put this, looks like we did put it on Dropbox. We're using Dropbox as a kind of like a hackish repo. So let's go to Heavy Metal Cookies, and let's create another repo for this. So we're gonna go, repositories, just make a new one. We'll call it, chrono by date, not data, by date. Trash old Trija model. So this is also trash, but we want to make a note that, you know, the old Trija model that sparked our patent designs is probably in here. We're going to make it private. Chrono by date. Chrono by date, okay. And we're going to create it. And then we're also going to upload all of this to... So over here we're going to do git remote add GitHub master, or not master, what am I doing? The URL, enter git remote -v, git push. We see the GitHub up there, so we're going to do that. And then after we've pushed this up, which might actually be a little bit more beefy, was it like 200 megabytes or something? I don't know, it's a lot. So we're going to kind of push that up so that we can kind of forget about it, right? We're trying to reduce the waste that is on our thumb drive because we have this main code base that we're trying to focus on, and we just ran out of room on our thumb drive, and that could be devastating to us. And then what else do we want to clean up after this? I think that'll be good enough for now. I think we just need to do a little bit of cleanup just to make sure we're not trying to save files and then we can't get anything to work because we literally have no room. The reason I think we were able to save the current files that we're working in is because when the file system makes partitions for like a file, it has a certain block size that you get. Like if a file is, say, let's exaggerate it. If a file is 1 bit, it wouldn't be able to reserve just 1 bit. In the same way that you can't have a variable that's just 1 bit, right? You need at least 8 bytes, or sorry, not 8 bytes, but 8 bits, right? For your smallest data type, for the smallest word size that the processor can handle. Same thing with making files. When you allocate space for a file, the block size needs to be some type of integer, some type of multiple of some type of number. I don't know what number, but it needs to be a multiple of something or other. So maybe the smallest allocation is, 32 kilobytes or something, right? And so when you try to save some changes you made to a text file, the text file is under 32 kilobytes still, so you don't need to edit the block size. So even though the hard drive is out of space, you can edit that text file and nothing catastrophic happens. So, but still, that still is not a place you want to play around with, right? That's still kind of like treading on thin ice. And the only reason I caught that was because one of my auto commit scripts was like, hey, we can't push or something. It said we couldn't commit, something or like that. And I knew that usually means that I'm out of hard disk space somewhere. Or not necessarily hard disk space, right? Because it's a flash drive, so it's not a hard disk. But I'm out of disk space. And I guess it's not really a disk. I guess disk is a... right, when we say disk space, we don't really mean disks anymore. We're out of storage space. We're out of physical storage space. There we go. This is taking a bit. But yeah, once this is pushed up, I think I've done enough backing up of stuff where I think we've like freed up enough space. Right, we're going to delete this folder, but we're going to confirm that all of these stuff is up on GitHub first. And then we'll delete this folder. And this is taking forever. And I know it's because like this is actually a lot of data. This folder was, I think, 200 megabytes. Maybe... Okay, so there we go. So let's do a git status really quick before we close this. Git status. Okay, and then just to exit the terminal, which I usually don't do properly. Let's refresh this, make sure everything's there. Oh, hey, we have all this stuff. Okay, excellent, excellent, excellent. Now let's close it and forget about it forever. Okay, so now this thing here, chrono by date, we can delete this. And I believe tree repos was not supposed to be... No, tree repos is repos with a working directory. So I kind of have my code kind of split into multiple places on this drive. Okay, there we go. So let's actually take a look at the R drive now, which is where I have my code. And see, we got, so we have, 464 megabytes free. So we're still kind of pretty packed on here. And eventually, I know AutoHotkey 3 is over here. So, like, when we're looking at gigs and gigs, like, one of those gigs is probably just in this guy here. So let's look at this guy. Yeah, so this thing is our many gigs of stuff, and we also have this old AutoHotkey thing. And that's just 100 megabytes. So I think we could take the old AutoHotkey. I know I said I was done here, but let's take the old AutoHotkey, and auto backup is probably a thing that we're kind of using. Heroku, I probably have a lot of Heroku stuff, right? This is probably not just a... Oh, no. I probably have a different Heroku folder with more stuff. Resume, JMIM, resumes. Things that I probably don't want to ever work on again. Oh boy, 1.63 gigabytes, huh? How the hell does that end up being so many gigabytes? This is why I don't do JavaScript development, because you try to do stuff and Zingerman's? Or is it just literally the index that's taking up all that space? Looks like it's the index. Why would the index take up that much? Okay, hold on. No, that's fine. Why was I seeing a whole bunch of gigabyte? Whatever. Let's take this resume thing as well. Let's kind of shove that as well. I know I said we were done here, but no, let's just kind of keep on housekeeping a little bit more. So we're just going to go back to GitHub, www.github.com. Alright, so this is mostly a maintenance day, I guess. So that's what it's turning into. Let's just take one more thing, and then eventually all I want is, like, maybe auto-hop. Well, right, we're going to kind of whittle down. We got to decide, what do we want to focus on with our life, right? And there's all these different technologies we can use, but we need to settle on something so that we can put, like, a very concentrated effort into that code. And we've explored and dabbled in a whole bunch of things, and that's good, because all the experience of having done all these different languages is good for us in terms of being able to understand things and be better programmers. It makes us better programmers to experiment with tons of things, but it does not make for making a viable product, right? A viable product needs a lot of focus and energy in one spot. So that kind of sucks that being a better programmer and creating a quality code base, there are two different endeavors, and so you kind of, like, you gotta do, like, one or the other, almost. Right? You can't really do both at the same time, I don't think. So resume, JMIM. So we're gonna call it resume, resume, JMIM. Trash. Okay, we'll make it private. We're going to create it. And then we're going to take this and we're going to do a git bash here. Oh, so it's like double wrapped. That's stupid. Git bash here. Git status. Then we're going to add this git remote once the status is... Okay, so git remote-v. Make sure... Okay, yep. So git remote add. We're going to call it GitHub. And paste what we found. Git remote-v. Git push git hub master. Okay, push that, we're going to delete that, and then I think we're done. It's just, I want enough space to feel like, okay, we can actually kind of keep working. And also, if you noticed, I'm doing everything on these thumb drives, and that's kind of a reason for my kind of, like, split down my, minimalistic work environment, because I want to do things in environments where even if I end up in a horrible situation one day where I have to code at the library, let's say, like I don't know, I end up homeless or something, and I gotta code at the library now. I want to be able to actually do that code. I want to be like, I want to be able to do it, right? So I want to keep my code base so simple that I can keep on working on stuff no matter what happens, right? That the technology, now the algorithms and things are kind of complicated and whatnot, but the tech stack, I want to keep it just simple. I want to keep the tech stack simple. I want to keep the tools simple so that I can kind of work on this wherever, whenever, I don't always need the latest and greatest, because that would be kind of the worst thing to me. It'd be like, oh, your house burnt down, you got no money. It's going to take you months just to get the tools that you need to work on code again. You know? Or worse yet, could be horrible things has happened, and even if you get the tools you need a gigantic computer that needs electricity and whatnot, so now you need an apartment, and you can't afford that or something for some reason, and so now you still can't work on it. Whereas if we keep everything simple enough, then, you know, even if we lose everything, we can go find a job, get a laptop eventually, start working at coffee shops or something, and just keep on coding, right? So we just want to be able to keep on coding no matter what. So git status, git remote -v. Okay, so that looks good to me. So if we refresh this, we should be able to see all this kind of resume stuff kind of thrown up there. Cool. Now that that's there, we're going to delete this JMIM resume thing. That's kind of doubly nested in the first place, which is stupid. And I also think I want to get rid of JMJS. Alright, since we're doing this, might as well. So let's do a git bash here and see if there is a remote for this. Git remote -v, git status, and let's go over here and create one more repo again. So in my repositories, we're gonna do new. This one's JMJS, it's private, and JMJS, trash. We work only in C code from now on for the rest of our life. 2020, 12. So I want to see how true this is going to be, but I think I'm going to stick with C for the rest of my life, just because there's all these different languages I can do, but JavaScript, in the end, just ends up making toy things. It just ends up making toy projects. I'm always limited by file system access or some other stupid workaround. It's great for prototyping things really fast. I like it, but I think it's just a toy. Now, I get that people want to be able to do things in JavaScript because then people can, like, play games on the web and whatnot, and they don't have to download anything, but with that, you actually eliminate some potential profit revenue, because people can just automatically play it on the web. They don't have to install anything. And who wants to pay money for something that they can just go to a URL and play? Nobody wants to, right? The profit model for JavaScript doesn't make sense to me, and the level of power I get out of making something in JavaScript also doesn't make sense to me. So I think that the JavaScript is a bad idea. I think that it's fun to do. And I'm sure I'll write more JavaScript in the future, probably. Even though they say we work on C code. So we're going to try to stick to only C code, though. Even though it's faster to develop in JavaScript. So we're going to make that private. JMJS, create repository. And then we're going to take this, copy, and do a git remote -v, git remote add. We're going to call it GitHub. Oh, actually, GitHub with a space. We're going to paste that URL. And then after that, git remote -v, check that it's there. And then we're going to do a git push GitHub master. Yeah, so git status, git push GitHub master. Okay, once you push this up, we're going to delete this from our file system as well, and that can't be corrected. Oh, did we already push it? Did we just push it and then we weren't paying attention? Is that what we just did? That may have been what we just did, because we're trying to, like, talk and do things at the same time. Yeah, so ported from Mercurial, really. Oh god, so Mercurial, huh? So Mercurial was, yeah, I used to use Mercurial just because the UI is a lot easier to use for Mercurial, and that's kind of how I was introduced to version control. And I still think that the tree view for that is nice. I think there's some add-ons you can use for Git to have a nice little Mercurial style tree view of everything, but let's see if we have more commits now. Yeah, so this was completely blank, I think, and now we have like a little stuff here, I believe. Or maybe not, maybe I'm imagining it, because this is still kind of the same weird-ass cluster. It's like, no code, and then all of a sudden, July, August, some stuff, and then nothing. Like, that is so weird. Okay, so let's take this, and now that we're kind of sure that that's up there, let's actually make absolutely sure, because I'm kind of scared. Repositories. JMJS was the last thing updated 2 minutes ago, right? All this stuff. Okay, yeah, I'm satisfied that we just kind of covered this. And how much memory are we getting back from doing this? Not much. Only like 4 megabytes. So some of this stuff doesn't take up much room because... God damn it. So this is what we get for... I think we just... Oh, our console is up here. Hold on. This console here. We're going to exit this. Okay, if we exit that console, now we should be able to delete this. And this Heroku folder, I'm going to guess we have, like, another Heroku folder, like, in Git. Yeah, so Git, and then we have, like... Oh, no, it's Git Heroku, so I think it's GH. We have specifically a folder just for Heroku stuff, because we do a lot. We're going to take... So we obviously have Heroku stuff in more than one spot, right? And this productivity summary thing, let's look at the properties. We got like 18 megabytes. I did not mean to hit apply. Git bash here. Let's see what we have for remotes. Git remote. One of the remotes should be Heroku. We got Dropbox, but okay. So let's go to here. Let's do something for this if it doesn't already exist. It may already exist, but just we might not have the remote for this one. So it's called JM Productivity Summary. JM Productivity Summary. I really don't like the dashes there, so let's do JM Productivity Summary. So that's another reason why I don't like this. So that's available. Let's make sure that the dash version is... Okay, so neither of those are used. I'm not a fan of dashes, so we're gonna write it like this and just say trash, or maybe not. Is this JMIM? So maybe this is trash, maybe this is just a backup. I'm not sure. Let's not worry about it. We can worry about that later when we're... Like, we have the URL for our tech demos page if we need to find it. And then we can kind of hunt down... We can hunt down whatever we need later. So we're going to make this private. We're going to create it. I'm going to grab that GitHub URL. And we're going to push this up there as well. So we have a version of it. We have all of this backed up on Heroku. But we need to also put it up on GitHub. Git remote-v. So actually, I would kind of expect this. Hold on. I would expect this to change my contribution history, because we pushed up a whole bunch of stuff. We've done... Usually when I do Heroku, we use a lot of commits, because every time you want to push up a change, you have to store it in version control. So this could actually drastically change my contribution history. So git remote-v, git push, and then GitHub master. But so before we do that, I want to check on GitHub. I want to see www.github.com. I want to look at my 2017 contribution history graph thing here. So your profile, this should be like 2017. We can check the date of the files, but in 2017 here, we don't have much. And if we look at one of these files, I bet they're from like 2017. 2017, yeah. So let's see. We don't have anything in September, I bet. So let's look at this. So September, there's like these little 2 dots here. I bet this is going to light up in a big chunk over here near September once we do this. So we're going to take a look at that and git push GitHub master. So I'm thinking that once I do this and I refresh that page, we're going to see like a whole bunch of stuff light up. So I'm just guessing that this contribution graph is just going to be like, I could be wrong, but let's kind of see what happens. Okay, so git status. Not what I wanted. Okay, and then we're gonna exit this, and let's kind of look at this and see if we get more stuff kind of lighting. Yep, there we go. Look, we got some stuff around September just lighting up. So that's cool. This is still like that, but right. So the things from the past, because I was wondering like, oh, look at that. But then there's like this exponential kind of like. There's this exponential difference between the years, and I'm like, I'm sure I am writing more code and being more consistent about things, but geez, that's crazy. Okay, so now let's look at this, right? So now we should see like all the files. Looks good to me. Node.js getting started. Bare bones, right? So we used Node.js for this. And we just started with the Node.js getting started file. So that's kind of why there's, like, I don't usually write metadata files, readme.md. Okay, so the next thing, what else do we have here? So we're ready to nuke this, and we remove the terminal, so we can get rid of these 18 megabytes. This is like, this is just like a little thing, right? It's like, it doesn't really, it's little. It doesn't take up much space, but this is more of reducing clutter, where when we're trying to find where mempalace clone how to. See what that's all about. Git remote -v, git remote rm origin, git remote -v, something something, r drive, remove origin. I don't see why we need this. I'm just going to put this in my shortcuts and my commentaries. And just say, I don't think I'm ever going to need this, but mempalace clone how to txt. Okay, so we're just gonna offboard that, and there's other things. We got clone tree how to, so that we should probably kind of put that somewhere as well. But for now, we can take this thing and we can kind of get rid of this. This really should be in version control rather than at the root like that. But I kind of see why I probably did that, but still, that's kind of sucks. So, auto backup. So, auto hotkey 3 is taking up a lot of room. This auto hotkey, this would be auto hotkey 1. We can get rid of that. So, git bash here, because this was really old stuff where we're just trying to, like, we have some old, like, documentation and things, but just to git status and see if, do we have a... Is there anything that needs to be committed that would suck? Because we don't want to have a code base that we've never touched in like years and years and years, and there's stuff that hasn't been committed. That would really suck, but it could happen, so we want to check the status here. Okay, looks good. Git remote -v. Let's see what kind of remotes we have. So we kind of used Dropbox for this. Let's take this guy and set up a remote for it. So git bash here. Let's do auto hotkey 1. We'll call it auto hotkey 01 because we know we have different auto hotkeys now. So your repositories. New. I'm going to call it AHK01. Trash. We have been on AHK03 for about 3 years. Today's date, 2020, 12/31. Make this private. So this is also trash. Alright, the idea is we're just, if we have the space, we're just going to back things up. But we're probably never going to look at them again. Git status. Git remote. Add GitHub. And then we're going to paste this. Git status. Git push GitHub, right? Because we know we're already, everything's already been committed, everything's already up to date with whatever that other remote is, so we can just push this up to GitHub, and then we will delete this one as well. Right, and this doesn't take up as much memory as some of the other things we cleaned up, but we also notice that we're kind of nickeling and diming ourselves to death with all these little tiny repos, and it also distracts us from finding things that are actually important. So the things that are not important to us anymore, we're just going to back them up and remove them from our local hard drive. And yeah, so this is turning into kind of a cleanup day, but if it's something that needs to be done, then why not now? Especially because since we don't feel like super highly motivated to write code right now, then it's the time to kind of do this. It's kind of like when I do dishes or clean stuff up, like do mindless chores. I kind of wait till my brain is fried and I can't do any hard brain work, right? When I can't do any hard brain work, then I can concentrate on the things that they're not mentally hard, but they just need to be done. They just take time, right? And so this stuff I'm doing right now, it's not mentally hard, it just takes time. And so I don't feel motivated to really work on code. We can take that time to just back stuff up, right? There's other things to do, right? There's other things to do besides the monumental effort of writing super complicated code. It'd be nice if the only thing we had to do was write complicated code, and then when we didn't feel like writing complicated code, we could just slack off and not do anything at all. That'd be great, but that's not the case. So let's do a git status for good measure, and a git remote -v. Okay, I'm satisfied. So we're gonna exit. We're gonna refresh this. We should see kind of a list of stuff. AutoHotkey. Ooh, look, I did a little metadata thing. Oh my god, look at this. HTML, AutoHotkey, JavaScript, Java, C++, CSS, batch file. Yeah, so you can tell this is an AutoHotkey repo because, like, all the stuff, all the little things, snippets for all the different languages as I'm touching, right? So that actually makes sense that this would have all these different languages. So it's not surprising. So this AutoHotkey, we're going to delete that. So bye-bye. Actually, before we go bye-bye, so almost 100 megabytes on disk, so delete this. So we're getting better here. Okay. So now, if we look at the R drive, let's just take a look. I'm sure we're still pretty full, but we have like enough room to kind of work with stuff. So we have 747 megabytes. We're still kind of like, this thing's still kind of full, which that still kind of sucks. But a lot of that is probably, that's the wrong drive. A lot of that's probably in, it's probably in my big AutoHotkey repo. That's just a guess. Okay, so we're working on these tests. Finally, we're back again. And we want the test index. So we want the test index. So we're going to say TI, and just say, you know, test index, or test, we could do test row index if you really want to know what that means, right? And then int32, the base offset of test data, right? The base offset of the test data. Okay. And if we look at this, base offset is going to be the test index times the number of datum for a given test, right? So how many data points are here? Okay, and then to get the individual things, we're going to take the base, and then we're going to add the appropriate offsets, but we also need to look things up in the table, right? So the table of unit test code with the base offset plus 0 gives us the first kind of thing we need to know, right? And there's 7 things, so 1, we're Control-D'ing, so 3, 4, 5, 6, 7. Control-D to duplicate all that. We can column select all of this, and then we can paste this down here like that. Bam! Okay, now, 1, 2, 3, 4, 5, and 6 makes 7 items. Alright, so we have all of the inputs. Now, let's make sure that we did this correctly. So, qua exp lay, so I'm looking up here, making sure that these match what's here. Qua exp lay, then the locations, x and y, and the globals, x and y. So that is correct. That looks good to me. X's and y's, locals, globals. Excellent. Now, I already see a mistake. So these trap values, they need to be up above here. And the idea is we're going to set all these trap values, and then we're going to set this, and then if this is just a redundancy to say, you know, if we forgot here to do any of the things up here, then we're going to see those trap values. It may be kind of pointless, because you're like, well, it's the same exact block, so what's the point? But it's test code, right? It's test code, so we're going to... If we didn't do stupid things, then we wouldn't be writing test code, right? The whole point of test code is that we do stupid things, and so even if something seems redundant, we're always gonna kind of write it, right? Just because, yeah. Hold on. Aha. That is kind of creepy. So I have like I'm sitting in the basement and it's like sunset. And then I saw like this shadow change. And then I'm like, I saw a shadow change on the wall to my right. I look over to my left. And then I see somebody walking. So they walked past the basement window. Probably not an intruder or anything. Probably somebody, but I'm not worried about who it is, but that is still kind of scary. I never noticed that before, probably because where I was sitting before, that shadow is probably never in my line of sight. Yeah, because it was probably never in my peripheral vision before. Okay, so we have this function. We're going to take these values, and one of the problems, I think I already see a problem here. This global tx, global ty, that needs to be the expected, right? Because these are... Actually, no, these are expected values, right? Hold on, let me think about this for a second. Oh, okay. I see. Global picks to pane picks. So these actually need to be expected values. We have these here, and that's fine. Or these could be called actual. I don't know how we want to do that. I guess we could call these expected, or we could call these actuals. Actually, no, we should here. We're just gonna be verbose. So we're just gonna put the word actual in front of these. Actually, hold on. How do we want to do this? if we're thinking about general to specific, is actual and expected a specific thing, or is it a generic thing? And yeah, let's think about that. So you have tile quadrant. Is tile quadrant more general, or is it more specific than, say, expected and actual? I'd say expected and actual are these kind of very broad categories, and therefore, if we're going to go general to specific, it would make most sense to have these are the actual values. Yeah. With that, when we're kind of coding all of this, most of these are expected values, but this last thing here, is actual, isn't it? Yeah, it's an actual because it's an input. Yeah, that's right. Yeah, that is right. So this is an actual. So most are expected. Values, expected values, except the global values, which are actual. Okay. So we can make a note here about what's expected and what's actual. So we could do @vid iid and 0069, and the time is 1 hour 36 minutes and 33 seconds. Oh yeah, so most of these things are expected values, so exp here for expected, but then these last things are the actual values. And these are all going to be extracted from our test data here. So right here, this big test table here, these are actual values, and these are the expected values because of the way our test function works. Because it's global pixels to pane pixels. So the global pixels right here are our inputs. Oh boy, I wrote that completely wrong. Now I think the reason I wrote it completely wrong is because usually I put output parameters as the thing on the end, but here we kept the signatures for both of these functions, glockpix to painpix and painpix to glockpix. The complementary functions, I gave them the exact same signature in terms of the order of the variable names, and just changed what was a pointer and what was not. So these are now outputs. Alright, so those are outputs. My bad. So right here we see everything says actual, but yeah, these are all actuals, right? Because it's all going into this function, so of course everything would be actual here. So eventually we're going to need actual and expecteds for everything. So we see cdiag glowpix, that's fine, but we're going to have to duplicate all of this. And before, well, whatever, let's just do it like this. And we need to change some things between, let's do actuals first, actuals and expecteds. And then we can kind of whittle this away a bit. So 1, 2, 3, and that's kind of symmetrical right there. So let's delete something on this side, and then let's also delete, let's make sure. Yeah, okay. So this is 1 too big to make it centered. So let's delete something on this side, and then kind of space this over here like this, right? Okay, cool. So we got actual and expected values. So we can make a note of that. So this is, you know, actual ACT values. 0069. And the time is 1 hour 39. We'll do 1 hour and 40 minutes. We don't have much room here. And we'll do the same thing for the expected values, right? We don't have much room. Let's just try to kind of cram that in. So we got the actual values and the expected values. And expected is going to be EXP values. And now we're kind of like out of room here. So let's just call this, I don't know, vals. And hopefully we're kind of smart enough to look at vals and values and know what that means. So all of our actual values are going to start with ACT. All of our expected values are going to start with EXP. And it's all the same things in the same order. So the tile quadrant, the tile exponent, the tile layer, our local TX and our local TY, our global TX and our global TY, right? So it's just find and replaced. Also, actual and expected are at the beginning because they're the most general category, and when we're trying to name our variables, we're trying to name everything in a general to specific order. This diaglopix should be over here. So if you want to take a look at, well, where are we going to find this kind of information? We can see, oh, this is diaglopix over here. Some of these other diagrams also pertain to this, but it looks like this is the diagram that, I guess, most pertains to knowing what all the variables are. But this diagram here is still valid. In fact, this is like the master diagram as far as I'm concerned. That's why it's going to at the top of the file. Okay. So going down further, we have our test cases. We have 4 test cases just to keep it simple for now until we get all of the loose ends taken care of and we can compile again. These things are now, what are these? Okay, so most of these, right, most of these are expected values, and these 2 are the actual values. Because we have these actuals and whatnot. So right here where we're loading these, we need to load them in that same order. So expected and the actual, so these are all the same thing. And to keep this kind of simpler or easier to work with, I don't know, this interlacing here kind of annoys me. I know why it's done that way, but that's kind of, it's kind of scaring me here. So these are actuals, but they're expecteds over here. This is here. This is an actual. And these are actuals, but are we setting... So the actual... We're never going to compare the globals here, right? Because it's global to whatever, right? It's global to... Glockfix to PAINT5D, so we never actually compare these globals, right? So there's no... We don't need an expected for the global, do we? For the global TXTY, right? That's just an input, right? And because that's an input, what we might want to do is, we have these expected and actuals, and the global is actually neither. It's just an input, really. So what we could do is we could whittle this down. We could take that off, and to avoid some confusing with our naming conventions, and we could just call this input. Right? So the idea is we have these actual values that we're going to kind of put in these are the actual values that we're going to get back by reference. That's what's kind of confusing. They're actual values, but we don't actually set them. They're just the actual values that we take pointer references to get back the results. And these are the expected results. And then these are just inputs because we don't actually want to compare these against anything, right? So, input only values. Right? And at vid IID 0069. And the time is 1 hour and we'll say 45 minutes. That gives us a little time to kind of clean this up. let's say input values. So they're input only values, but they don't have much room to write all that. So let's just call it input only values and hope that kind of satisfies us for now, right? So these are input only values. The global tx and global ty, they don't actually need to be values that we are checking. Now, can we kind of center this or no? Yeah, we can kind of move this around a bit. So let's take this right here, let's copy this, and let's kind of clean this up a bit. So we were a little bit wrong about what was actual and expected. Okay. So now that we have these different actuals and expecteds, we got to look at global tx and global ty, because we're going to have places where we assigned values of that don't actually exist. So this global tx, global ty, for the actual, that's not going to be an actual, that's going to be called the in, right? So we have the expected, and then we have the input. So you have some inputs and some expected values, but there shouldn't be anything called actual when we're loading the test values, right? Because when we're loading the test values, really, there's no actuals yet because we haven't actually ran the code. Now that is kind of weird to do it that way, right? But we're saying that all these are actuals, but this one is an input, right? Because this one's not actually going to get changed, right? It's only these ones with the outputs that are actually going to be changed that we're going to compare against things. These ones, these two inputs, we're not actually going to compare against anything, right? So now that we have that more organized, we can start comparing all of our expected and actuals. So if, you know, expected til qua is not equal to, you know, the actual til qua, and we're going to do a 0 here, and we're going to try to make this kind of streamlined here. We know we have 5 things, right? Because we're not going to do these 2 things of the 7, so we're going to have 1, 2, 3, 4, 5. 5 things we need to compare. So paste this 5 times with Control-D to duplicate. And we're going to take these 5 names right here with a column select. And this is why it's nice to do everything in a very strict order, because then you can just be like, a lot of this is like cut and paste. A lot of code is just very redundant. And so if you organize it this way, you can kind of save some time. So if we're in here, if any of these things are not equal to any of those other things, then we kind of failed the test, right? So the expecteds are not equal to the actuals, then we failed. So we are going to say, you know, printf, let's just do like, let's just call it qua. Let's be shorthand about this. %d. Let's do %d and %d. Like this. And then a new line. And then we can do the actual and expecteds on the same line and do like, you know, like that. And if we got that syntax correct, right, we're hoping that we don't make any syntax mistakes, because all the mistakes we make are going to be multiplied. But let's take this and do a template here. And let's just take the source code. Let's look for anywhere we have this, and let's just replace it with, actually not where let's look for just til qua like this. Let's take all of these right here. Let's paste them down here. Oop. Not like that, though. Let's make some more room. Okay, let's paste them down here. So we have enough stuff to kind of auto-generate all of those printf statements. Okay, so now we have all our printf statements, and the first one right here is duplicated, so we can just remove that. And this is just so, you know, if the test does fail, we just want some way to see all the printouts. And the last thing is we want to err and say, you know, fail. We can say We're failing paint. We're failing Glock picks to paint picks. We don't need to be more specific than that. That should be fine. We have a to-do message. Now we have all this code here, but we don't have a loop, right? We're trying to loop through all this stuff. We have TI here. TI and the base value is set from here. So now we just got to put everything into a loop, and we already indented properly to where we don't have to change the indentation. So it looks like we're already thinking about that. But so we're going to do for the test index equals 0. The test index is less than or equal to, and we're going to take the number of test cases. So we have the number of test cases for Glock picks to paint picks. So we're doing Glock picks to paint picks. And we have the test cases here. And we'll take that and just say less than or equal to the number of test cases minus 1. And that's too big. So we're going to do some type of macro or max index. Or we'll do this, TI max or MI. I usually use MI for max index. So we could do like this, MI for max index, TI MI, and then TI++. We don't really care about, oh, that should really be a macro, that max index. We don't really need that to be a variable. We're not going to worry about that because it's a test. It's a test. I'm not really worried about performance in terms of tests. So for this max index, we could probably put it next to all this stuff here, I think would make sense. So we're going to do int32 and mi, and this is going to equal, you know, right, and mi is max index. So, variables for iterating through our test cases. MI means max index, inclusive. Right, so we might want to make a note of what MI means, because we kind of ran out of room to where we're going to write that. And we already made a mistake, right? Max index inclusive, so we need to minus 1 here. Yeah. And this is why I'm saying we really don't want to be writing these tests right now, because there's the potential that there's going to be a lot of mistakes in our test code. But the thing is we have all these loose ends, and we have to mitigate the damage we're doing. And unfortunately, there's no perfect solution for where we are right now. We have to just keep on chugging away, try to be as careful as we can, make sure we get all the loose ends. Hopefully we're getting them all. Maybe we're missing some things, right? So video integer ID is 0069, and the time is 1 hour, 52 minutes, and 50 seconds. So to iterate or reiterate what's going on here, I'm just making a note of what these 3 variables are. So this is the test row index. So this is the test case that we're currently on when we're iterating through our table of test cases right here. The base is for the base offset for when we're trying to extract the test data. So you can see that there's a little formula here. We have this base plus 0, 1, 2, 3, 4, 5, 6, right? So this is the first piece of data for the test, second piece of data for the test, third, fourth, fifth, sixth, and seventh, right? So we're getting all the individual test cases from a single row, but we need the base offset to know where this first element is, right? The first element plus 0, or the base index plus 0, base index plus 1, base index plus 2, etc., etc. So that looks good. And then also, let's explain MI, max index. It's usually an inclusive value, the way I code it. So I made a note that it's an inclusive range. We take the number of test cases, and is that correct? Yes, the number of test cases, because we want to iterate through all the tests. We're going to minus 1 to get an inclusive range. And we can see the usage of it right here with a less than or equal to symbol. So test index, iterate through all the test indices, figure out what the base index is, set some trap values, set the actual values for the test case, call the function to get these actual values that we're now going to need to check against those expected values. And if we fail any of these checks, we're just going to print off everything so we can see what's right, what's wrong. And then we're going to say error and say we failed and, give a little notification on, what we failed. Then we have a to-do manager because we need to add more tests for this function eventually. But right now we just want to stub something in and move on because right now we just want to concentrate on eliminating loose ends. Okay. So up here we have, okay, we already have the error function. Great, great, great. The next thing we want to do is work on PAINT5D to GlockPick. So it's the exact same thing, it's just the other way around. So a lot of the variable names, are going to just be, just need to be like renamed and shifted around a bit. So what we're going to do is we're going to take all of this code, even this to-do message, we're going to take it all of this code. And we're just going to cut-paste it, and then work it around. And when we cut-paste it, we're also going to remove some of these timestamps, because these timestamps are no longer valid for this test, right? We're just going to cut and paste, and we can change this message, so it's still the same date, but it's now like 5:04. So 5:04 p.m. We need to do some push-ups. We need to do like 20 push-ups, 20 crunches, and 20 squats. It's almost 2 hours. Okay, anywhere we see timestamps in here, we got to remove those because these are not, these timestamps So let's just remove this commentary. Even the timestamp and the commentary, if we want to add commentary in later, we can kind of do that. We're just going to remove this commentary. Anywhere we have commentary, we can write commentary in again. But right now, we're going to remove the commentary just because we're cutting and pasting, and I don't want to deal with it right now. We don't want to maintain the comments here right now. We just want to cut and paste and change things around. So this is PAINT5D to GlockPick. So the first thing we know is this function here is not the function down here. This is GlockPick to PAINT5D. We want to change this to PAINT5D to GlockPick. PAINT5D to GlockPick. When we do that, these actually are going to change to inputs. So these are going to be in. We're going to remove the ands around these. And these are going to be the actuals. So we only have 2 actuals now, right? And you can see kind of why I didn't change, right, usually the output parameters are always at the end, but you can see why I didn't do that, because then I could just take this and kind of change where these things are, like which ones are pointers, and it just seems more complementary. These functions seem more complementary in this way than the other way that I could have done it. That's why I did it, and so I kind of broke the pattern of output parameters are always last. But now output parameters are last, so we can change this to outputs. And we can change this to inputs. And then we can, make that aligned a little bit better. And these variable names aren't all correct, are they? Because now we can keep this table kind of the same. And, right, all these test cases we can keep exactly the same. It's just we got to change what's considered an input, what's considered an output. And so all these trap values are being taken out of this test table. These are now inputs. And this right here is an expected value. These are still all inputs, right? We're going to extract the inputs, but these 2 parameters for the global, those are just expected values. So you can see we're putting in all the inputs that we're extracting from the data table. And then expected is not being used in the function call. We're just doing global because this is a return, right? And then over here is we're going to check the expected against the actuals. And right now there's only going to be 2 of these now. We only have 2 actual things. So we can take this and go remove this and replace with global tx, global ty. So copy this, paste this, and paste this. And you can see why the more regular you are with your code, the easier it's going to be to do things, because a lot of this is very mindless cut and paste kind of work. And that is by design, right? We want to eliminate as much stupid decisions as possible. So we're gonna just call this I'm gonna just call this glow.tx. We can call this glow.ty. And then the variables, we can say expected and actual is what we've been doing. So expected and actual, and then expected and actual. And then just make sure they match. So here, 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 and here. Looks good. Glow.tx, glow.ty. Glockpix to PAINPix, is that true? Or are we in the other thing? I think we're in the other thing, are we not? PAINPix to Glockpix. So we gotta invert this message. PAINPix C to Glockpix. Okay. This vital to-do message we've changed. So everything looks almost good, but I'm sure that some of these variable declarations are not correct. So yeah, these are inputs now. So all of these things are inputs. The expected values are not what we want. Yeah, so these are now all inputs. These are input values. And then we have some expected and actuals. So I don't really care too much about this, but let's just do this and do glow.tx and glow.ty. So we have expected and actual. In the order, I don't really know what the order should be here. Will we do expected and actual? That seems to be the ordering there. And then inputs, expected, and actuals. I don't know. I don't really have a habit for the exact ordering of this, so let's not worry too much. Expected, actuals, txty, txty, globals. All right, we're only checking the globals this time for expected and actual values. So what we could do, I think might make sense here for this section, is we have like this space to breathe right here, which is nice because then we can see some logical grouping here. But then you got to think that even though these are grouped, and these are grouped, together they're a group in themselves, right? These are a group in themselves. So what we could do is we could make the comment over to this side kind of indicate that we have some type of grouping, right? We have a hierarchy, right? And then here we can take this message and we can try to figure out where it goes in kind of the middle here. And I don't know, so let's just kind of whittle away at this a bit and get kind of overly designy, just so that we can kind of visually poke out where that middle is, because I think we do have an exact middle. Yes, we do. So if we have an exact middle, I like to be symmetrical about things. I know it's not necessary. People are going to say the design of the code does not matter. Like the visual aspect of it doesn't matter, but I think it matters. Not as much as working code. Working code, absolutely true that working code is the main thing here. So let's do @vid iid and just do 0069, and the time is 02 hours, 03 minutes, and 32 seconds. And just say visually organize our inputs, expected outputs, and actual outputs in a visually friendly manner. Sorry, I went to art school. Alright, so just a little note about what we're doing over here. in case you're looking at the block down there and you're like, what is that all about? Why are you aligning things? I think it's probably already obvious about why we align things. So I guess the most important information here that we've just written is that, you know, exp star is expected, act star is actual values, and then we have input star is the inputs. And you know what? I actually hate this comment here. In star input values expected outputs and actual star is actual out. I don't like being confronted with big walls of text, and if the information that is in a wall of text could actually be displayed in a table, I want to display it in a table, just because my attention span, I don't know what it is. It's probably just being dyslexic or something, or maybe it's just human nature, but I digest tabular information much easier than I digest big, long paragraphs. So actually, I like this a little bit better. Let's change the timestamp, so it's 2 hours, 5 minutes, and 55 seconds, we'll say. 55 seconds. Okay, right? So this is the prefix for inputs, prefix for outputs. Sorry. Inputs, expected outputs, actual... What the hell? Actual outputs, there we go. And then they're all down here. So we could take this and we could actually boom, boom, boom. Isn't that nice? I can use our token highlighting to immediately see that that's all grouped properly. So I actually like that. It kind of also serves as a tool in the code for finding things. So I like that. This thing is improper. This is not correct. It is GlockPix to PAINPix cases, but if we think about where we are right now, we're not in GlockPix to PAINPix anymore. We kind of cut and paste, and we see this is PAINPix to GlockPix. So we're going to take this token here, and we're going to take this token here.
Hey.
Yes, how's it going?
Hot cocoa, and also luminaries.
What are... Oh, God, that...
Yeah,
that
we're
stuff.
doing a thing. Also, I got this, and I have to teach you how to use it.
I see. Okay, hold on. Let's... Okay.
Should probably take a quick 15-minute break, tops.
Okay. Luminaries is probably going to take... What are you talking about? Luminaries?
I'm trying to be nice.
That's going to take more than 15 fucking minutes. That bullshit.
Whoa.
Why are we...
accurate, but come on.
Why are we doing this?
Because we're trying to be hospitable to your mom and the kids.
I think it's called we're trying to do things with the neighborhood associations so they don't hate our fucking guts and make our lives harder. Yeah, I'm sure they already...
When I see those teenagers from the other house that's on site, I'm gonna punch them.
Yeah. And first of all, you're not. Second of all, don't.
But I don't like them. They're rude.
They're teenagers.
They're rude.
You were just as big of a shithead when you were a teenager.
Maybe,
so
but I didn't fucking yell at people or launch golf balls at cars.
Or you could try to, you know, not... Yeah. Come on, there's a word for this.
Assault?
No. Accelerate, advance, exacerbate. Exacerbate? Yeah, okay. So anyways, let's break it.
That's the point. I still got to teach you how to use this really quick.
Okay, hold on. Let me highlight this one more time, make sure that this is in all the places we think it's supposed to be.
Mm-hmm.
Let me highlight this other thing, make sure it's not in any of those places. So everything should be orange here. Okay, that's good. Save that. Yeah, I gotta end the stream, because we know this is not gonna be
I'm sorry.
a fucking whatever thing.
Hey, you've been going for a couple hours, though, and you
Doing my push-ups. Doing my push-ups and crunches right now. Total today, we haven't done any today. Why does it say 40? That was probably yesterday.
Because you're very talented.
That was yesterday.
You did 40 without even thinking.
Okay, so I'm gonna do, it's 10 per hour, so it's like at 2 hours. So we should probably do 30 for good measure of each.
That's...
and I'm done.
Okay. Did you stop streaming?
No, this is part of the stream, man. This is doing push-ups.
Okay. Do you want me to count?
30 of each.
Okay.
For sure.
Drop it like it's hot. 1, 2, 3, 4. Nice.
No, when I'm up. Going down doesn't count.
Okay. 4, 5.
Make that 4.
4, 5, 6, 7, 8, 9, 10. Nice butt. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. You have great form and your butt looks great, and now that's on your stream forever. Your followers know that you have a really good butt. 2, 3, 4, 5, 6, 7, 8, 9. That wasn't full. 10, 11,
Don't tell me what's full.
12. There you go. 13, 14, 15, 16, 16, 17,
18.
Shit.
19. 20. Let me count.
I'm sorry. I keep
21.
getting distracted because you're cute.
22.
23.
23.
You're just too cute.
24.
And I keep looking at you and I keep
25.
getting distracted.
26. 27.
28. 29. 30. Now you get to learn.
No.
Oh.
Crunches.
Oh, I see.
3 things. We gotta fix that fat ass, and we gotta fix
You got such
fat
a
belly.
nice butt, though. I like it so much. Is this 3, 4, 5? Don't look at me. I'm gonna not. 6, 7, 8, 9. You're so cute. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I have a request.
We're also gonna address the fact that, somebody's house that burned down, Charlie, there shouldn't be like lighting fires in people's yards. It's just...
I would like to make a request. I think since you don't even show the camera anyways, the next time you do this, you should be shirtless. For my edification, if nothing less. Because we've been dating for 5 years, and I think I can make a request.
Yeah, I'm ending the stream now.
Okay.
Request has been logged.
Okay.
Actually, hold on. Let's look at the agenda screen. Agenda screen, and then... Let's see, where are we on next time?
Next time on.
Okay, so we're still on PAINT5D camera. We're kind of taking care of loose ends. We'll be hopefully back later today.
Hopefully.